Yeah, let me know whether I'm audible or not. Welcome to YourPedia. Welcome to YourPedia. Let me know whether I'm audible or not. Yes. Hello everyone. Welcome to YourPedia. Just let me know my audibility. Yes. Am I audible? Yes. I think I'm audible. Today, in this session, we are going to discuss some 50 most probable questions from power systems for oil India. Yes, these questions are for oil India. Though the font size is less, I'll be reading each and every question. I'll be reading each and every question. Font size is somewhat looking less. Don't worry. I'll read each and every question. So we are going to discuss questions for oil India for electrical engineering from the subject power system. From the subject power system. The first question, I'm reading the first question. I'm reading the first question. The very first question is a short transmission line. So the font may be somewhat less for you. You can zoom in, zoom in, you can zoom in. Okay. I'm reading it. I'm reading it outwardly. Yeah. A short transmission line having a series impedance of Z has the following parameters. He's saying that he's having a short transmission line which is having a series impedance of how much it is? Z ohms. How much it is? Z ohms. This way. Then what are the, so this is sending inside Vs and this is Is and this is Vr and this is Ir. He's asking the ABCD parameters of this one. The very simple thing, if there is only one series element, the ABCD parameters are, the ABCD parameter matrix is simply I can say that is 1 Z 0 1. Yeah, you can remember this. If you want, you can derive that one also, but the derivation is not our part. So in the examination, just if you want, that is derivation is very simple. But this one, if you want to derive, write KVL and write KCL also. Is is equal to IR. Is is equal to IR. So Is can be written as Is is equal to 0 VR plus 1 into IR. This is equation 2. The same way, you write the equation for Vs, you are going to get 1Z01. Answer is what? 1Z01. See, A equal to D equal to 1, B equal to Z, C is equal to 0. Yes, 1, Z, 0, 1. See, if you want more clarity, if you want more clarity, see, I'll take up here, I'll take up here that derivation, simple derivation. See, this is Z, this is Z, right? This is Vs, this is Vr. So plus minus I'm taking here minus Vs plus IR into Z. This is Is and this is IR. IR into Z plus VR is equal to 0. Now if you get Vs is equal to VR plus Z into IR, this is equation 1. Just I wrote the KVL. Just I wrote the KVL, right? Now Is is equal to IR, that is 0 into VR plus 1 into IR. This is equation 2. Compare these two equations with the standard equations. From that, you're going to get A equal to 1, B is equal to Z, C is equal to 0, D also equal to 1. So that is our first question. That is our first question. Any requirement if you have, you can directly message me in the chat box. I'll consider your request and that I'll follow what you want. See, I'll be taking whatever you want. Right. The second question: size of earth or ground wire. What is earth or ground wire? That is the wire which has to carry the fault. I can say lightning current. Earth wire or ground wire or shield wire. That is going to depend on. So I am saying again, font may be looking less. I am reading all four options very clearly. Size of earth or ground wire is going to depend on what? Option A, based on maximum fault current carrying through the ground wire. Option B, it's based on the rated current carrying capacity of the service line. Depends on the soil resistivity, both A and C. No, it depends on A. How much is the maximum fault current on that it is going to depend. How much is the maximum fault current on that it is going to depend. Third question, in a short transmission line, voltage regulation is zero when the power factor angle of the load at the receiving end side is equal to, simply, third question is for what power factor? For what load power factor angle the regulation voltage regulation is zero? The condition for zero voltage regulation is receiving end load power factor is equal to pi r is equal to pi by 2 minus theta, pi by 2 minus theta. Apply tan on both sides. Apply cos on both sides or tan on both sides. Then you're going to get where theta is equal to, where theta is equal to tan inverse of x by r. Theta is tan inverse of x by r. Yes, theta is tan inverse of x by r. Now, what is this? Phi r is equal to pi by 2 minus of tan inverse of x by r. Apply tan on both sides, so then you're going to get tan phi r is equal to, yes, you're going to get cot of x by r, or simply I can say this much not required. Very simply I can say, that is r by x it will become tan inverse of r by x. Option is simply B. Next question. So the corona loss of 400 kV 50 Hz system is 3 kilowatt per kilometer per phase. 3 kilowatt per kilometer per phase. What is the corona loss if the system operates for a DC with the same configuration? Good question it is. He's saying corona loss is how much? How much? 3 kilowatt per kilometer per phase of a 400 kV 50 Hz system. Now we know that corona loss is directly proportional to F plus 25. F plus 25. So from this one you solve, then you are going to get the option, right? Right? So P1 by P2. See, P1 by P2 is equal to F1 plus 25 by F2 plus 25. How much is this F2? F2 is 0 DC. F1 is 50. And P1, how much given? P1 is given as 3. Now from this one, you'll get P2 very easily. Solve this one for P2. See, all of you, I request all of you to solve for P2. That's all. It is very simple question. Next question. The diversity factor is the ratio of, number of times this question got repeated in many PSUs. The diversity factor is the ratio of sum of the individual maximum demands. Option is C. Sum of the individual maximum demands by simultaneous maximum demand of the entire group. Simultaneous maximum demand of the entire group. Please go through that load factor, diversity factor, plant capacity factor. These factors, at least 1% from that area you get in oil India examination. Let's go to the next question. See, font may look somewhat smaller to you. That's why I'm reading each and every question outwardly. Yeah. What is the question number 6? Next question. The next question is, yes. The next question what he is asking is, transposition of transmission lines is done. See, we have two types of configurations. One is symmetrical transmission and one is asymmetrical transmission. See how symmetrical looks. This is symmetrical. Phase A here, phase B here, phase C here. Means this distance, and this distance are equal. This is D, this is D, this is D. If all three distances are equal, it is called a symmetrical configuration. But with symmetrical configuration, I am able to send only three conductors at a time. If I am going for asymmetrical configuration, what is asymmetrical configuration? This is asymmetrical configuration. What is that? A here, B here, C here. The distances are not same. The distances are not same. Here again, A, B, C. If I am going like this, I am able to send the two circuits at a time on single tower. So practically, asymmetrical configuration is preferred. But because of that asymmetrical configuration, there are some disadvantages like L per phase, C per phase are not equal, due to which I can say voltage drops are not same. System is going to become unbalanced. Now, what are the options given? So, transposition of transmission lines is done to reduce line losses, no capacitive effect, no disturbance to nearby communication circuits, effect of surge voltages induced on the transmission line. Now, option is C. How option is C? I'll tell you. See, if not transposed, it is asymmetrical configuration and it is unbalanced, due to which some resultant flux is going to cut with the neighboring communication lines. This particular effect is called as radio interference. It is called as radio interference or TV interference or telephonic interference. That is because of unsymmetrical or asymmetrical configuration. If we go for transposition, then I can say that though it is asymmetrical configuration, all three conductors are going to experience all three positional GMDs due to which L per phase of phase A, phase B, phase C, C per phase of phase A, phase B, phase C are going to be equal, due to which voltage drop will remain same. Yes, and receiving and voltage are going to balance, and there is no resultant flux which is going to cut with neighboring communication lines, and radial interference is going to reduce. That's why option is C. Next question. Series compensation on EHV lines is resorted to. So series capacitor. He's asking about series capacitor. See, this is the transmission line. This is transmission line. Without series capacitor, the reactance is X. Without series capacitor, the reactance is X. With series capacitor, I am putting one series capacitor of minus J XC. This is X. Then the resultant capacitance is, the resultant reactance is. So this here X equal is equal to X here, X equal is equal to X minus XC. Now what is P max? Maximum power that can be transferred. That is mod Vs mod Vr by X in the first case. In the first case. In the second case, P max 2 is equal to mod Vs mod Vr by X minus XC. This is 2. Definitely 2 is greater than 1 because the denominator is reduced. The denominator is reduced, right? So the series compensation on EHV lines is resorted to improve stability. Yes, maximum power transfer capacity is increased, means definitely is stability is going to increase. Yes, power system stability is going to increase. If Pmax increases, what is our power equation? What is the approximate power transfer equation? Approximate real power transfer equation, that is P is equal to Pmax into sine delta. If I'm reducing the reactance, Pmax is increasing. For same power transfer, if Pmax is increasing, sine delta will decrease. Therefore, delta has to decrease. Less is delta, more is stability. More will be stability. Therefore, it is stability will increase. The ABCD constants of a short transmission line. This question is similar to the first one. What is a short transmission line? Short transmission line is a line in which shunt capacitance is neglected. Yes, shunt capacitance and shunt conductance are neglected. Short transmission line means only resistance and reactance, series reactance are considered. The shunt elements are neglected. This is R, this is Jx. Commonly, we call this one as Z. Then the ABCD parameters are 1Z01. Sorry, the ABCD parameters are 1Z01. The option is 1. A is 1, B is Z, C is 0, D is 1. Same kind of question as the first one, but there is something new thought here, that is a short transmission line. That's why we taken this question again. So all these questions are the questions. Some questions are previously asked questions in Oil India. Some questions are previously asked in various PSUs, which are similar type of questions. Which are having more probability for asking again in Oil India Limited examination for E, right? Next question. Advantage of using bundle conductors in transmission lines. Bundle conductors are going to increase stability, will decrease load angle, radio interference will be decreased. So like that, it is having lots of advantages. The main advantage of bundle conductors is to reduce corona. Read the options: reduce sag, increase mechanical strength of the line, reduces corona. Yes, I can say reduces corona. The main purpose of bundle conductors is to reduce electrical corona. Right? The next question. Question number 10. What is saying? When the spacing between the conductors in an overhead transmission line increased, he's saying that spacing you want to increase. So what is resistance? Resistance is R is equal to rho L by A. It is not going to depend on the spacing between two conductors. What is the inductance? X is equal to, or not X, L is equal to, what is the form of L? L per phase is equal to 2 into 10 to the power of minus 7 into ln of D. D is the distance between two phases or two conductors by R. R is the radius. D is not the diameter. D is the distance between two conductors. Now, what is saying? If this D is increased, obviously L is going to increase. What is C per phase formula? C per phase is equal to 2 pi epsilon naught epsilon R by ln of D by R. Here, if D is increased, yes, sir, D is increased. See, this particular ln of D by R, if D is increased, this particular one will increase and capacitance is going to decrease. If you are going with the increment of the distance between two conductors, capacitance per phase will decrease, inductance per phase will increase. These are the options. That line inductance decreases, no, option A is not correct. Option B, the line capacitance decreases but line inductance increases. Yes, the line capacitance is decreasing, inductance is increasing. Observe these options, right? Let's go to the next question. Let's go to the next question. What is saying? 800 kV transmission line is having a per phase line inductance of 1.1 millihenry per kilometer and per phase capacitance of 11.68 nanofarad per kilometer. Ignoring the length of the line, its ideal power transfer capacity in megawatts is, what is ideal power transfer capacity? Ideal power transfer capacity is surge impedance loading. Surge impedance loading is equal to V square by ZC, where ZC is equal to root of L by C. You have a value of L. How much it is? You have the value of L. A millihenry per kilometer. Both are in per kilometer. This is 1.1 into 10 to the power minus 3 by 11.68 into 10 to the power minus 9 ohms. You get ZC. Now, surge impedance loading in megawatt is equal to V square. What is the voltage? Is said 800 square by this ZC value. You are going to get the option. You solve it. I'm not going to solve it for the value. Just I'm giving you the all substitution of all the values very clearly. The next question. The inductance of a transmission line for a length of 400 km in asymmetrical configuration. Phase R is 30, phase Y is 20, phase B is 25. What will be the inductance of each transmission line after transposing? After transposing, it is going to be the average. See, LR is equal to Ly is equal to Lb is equal to average of all three. That is the advantage of transposition. 30 plus 20 plus 25 by 3. How much it is? 30 plus 20, 50. 50 plus 25, 75 by 3. It is 25 millihenry. It is 25 millihenry. So the option is C. See, that is the advantage of transposition. Transposition means we are exchanging the positions of the power conductors so that each conductor is going to experience all three positional GMTs, due to which inductance of all three phases is going to be equal, capacitance also going to be equal, due to which receiving and voltage will balance and entire power system network will be balanced. Right? Next question. Let's go to the next question. Yeah, what is saying here? A power factor meter is connected in a circuit that indicates power factor of 0.6. So present power factor is 0.6. What is power factor? Cos phi is equal to R by root of R square plus X square generally, right? To improve the power factor, what we have to insert the following component. Which component he is asking us to insert. See, we want to increase this one. You want to increase this one. Resistance will remain same. Then I want to decrease this one. So Z is equal to R plus JX. Now if I connect a capacitor in series, X minus XC, this is decreasing, power factor will increase. What are the options? Inductors, no. If you put inductor, Z is going to increase, the power factor is going to decrease. Second one is both inductors and resistors, no. Third one is capacitors, yes. If you put capacitor, reactance is going to decrease, power factor is going to improve, right? Next, an 800 kV transmission line has a maximum power transfer capacity of P when operated at 400 kV with the series reactance. The new maximum power transfer capacity is, let's read the question once again. An 800 kV transmission line has a maximum power transfer capacity of P. So with 800 kV, yes sir, the P max is equal to P, right? When operated at 400 kV with the series reactance, the new maximum. So if it is operated with 400 kV, this is PM1, what is Pmax 2 is asking? Pmax 2 is asking, right? Let's discuss that. Pmax is equal to mod Vs mod Vr by X. X is same. Let's take Vs is equal to Vr, then what it is? V square by X. Now you see here V is halved. Here V is halved. Then V square will be reduced. V square will be 1 by 4. See, here this is V1, this is PM1. Now next is a V2 square. V2 square by X is PM2. This is PM2. But a V2 is a V1 by 2. Therefore, PM2 will be V1 square by 4X. So V1 square by X is P. So PM2 is P by 4. Option is D, P by 4. So if voltage decreases by 1 time, then power decreases by 4 times. Right? Yeah. Next question. The disadvantage of low power factor is if power factor is less, that device is going to draw more current. See, S is equal to V into I. That is equal to P plus JQ. P plus JQ. Now it is drawing more reactive power. Power factor is less means the device will draw more reactive power. Then obviously current will increase. If current is increasing, obviously KVA rating or MVA rating is going to increase. The option is large KVA rating is required. Large KVA rating is required. Right? Let's go for the next question. Good question. The next question is good question. The next question is yes. I'll solve here in this border. Observe. What he's saying is the geometric mean radius of a conductor in terms of the radius r of an individual strand for three equal strands as shown below. What he's saying is he is having a conductor like this. It is a standard conductor. Each one is having radius of r. Each one is having radius of r. Right? I was asking what is the GMD? I can say geometric mean radius, a self GMD. GMR it is, but for a strand conductor it will be self GMD. What is the self GMD of the resultant conductor? So this is 1, this is 2, this is 3. I can say. Now what is GMR of strand 1? Its own is r dash with a neighbor 2r with another neighbor 2r. Again, this own is r dash. You know, when finding inductance, we'll take r dash instead of r. What is r dash? 0.7788 times of r, right? Into what is that distance between here to here? From here to here, the distance is 2r. From here to here, the distance is 2r, right? The distance is 2r. Yes or not? The distance is 2r. It is cube root of GMR of 1 also. Actually, I have written it as self GMD. Same. GMR of 3 also. Standard 3 also. Standard 3 also same. Now GMR of entire conductor is cube root of 1 into 2 into 3. That will be the same. That is cube root of r dash. How much is r dash? 0.7788 into r. That will be e power minus 0.5. You see, 0.7788 e power minus that you have to know with the calculator. Yes, sir. So this is the entire answer. It will be. Let me write the entire answer here. See. Resultant answer is the cube root of 0.7788 r into 2r into 2r. But this 0.7788 r is nothing but e power minus 1 by 4 into r into 2r into 2r. Minus 1 by 4 is nothing but minus 0.25. So tell me which option is suitable for us. See, for this question, cube root of e power minus 0.25 r into 2r into r. Option A is perfectly suitable. Option A is perfectly suitable. See, simple question it is. Yeah. In YourPedia exam, questions will be of like this only. Yeah. The capacitance of a 3-core cable between any two conductors with sheath at the is 2 microfarad. The per phase capacitance will be. See, per phase capacitance will be C1 by 3. It is how much it is? 2 microfarad. That fellow given. Yes, sir. 2 micro by 3. That is 0.667 microfarads. That is direct formula. Option is C. Option is C. This kind of questions were previously asked in oil examination. If you prepare underground cable concepts, then the question is going to be very easy for you. Next question is a good question. Somewhat analytically we have to do. Simple question. Okay. The insulation resistance of a 2 kilometer long cable is 150 ohm. So length L1 is 2 kilometer. And resistance R1 is how much? 150 mega ohm. 150 mega ohm. For a length of 20 kilometer, the insulation resistance is. If length is equal to 20 kilometer, then resistance R2 is dash mega ohm. Many people will apply some resistance is directly proportional to length. No, here in cable, that is leakage resistance or insulation resistance, that is inversely proportional to length. Inversely proportional to length. Right? Now, the distance is increased by 10 times, the resistance will decrease by 10 times. Therefore, answer is option B. See, general resistance is very much different from insulation resistance. General resistance is directly proportional to length, but whereas insulation resistance of a cable particularly is inversely proportional to length. That's why their length is increased from 2 kilometer to 20 kilometer. Length is increased by 10 times, therefore resistance will be decreased by 10 times. Right? Next. How can the steady state stability can be increased? Steady state stability. First of all, what is our equation? Electric power output equation is equal to P is equal to mod Vs mod Vr by X into sin delta. See, if we can decrease delta, then see, I want to maintain same P. If I'm decreasing delta by maintaining same P, then definitely I have to increase P max. This is P max. This particular product is P max. Then obviously I can say that stability is increased. And obviously I can say that stability is increased. What are the options? Increasing the excitation, yes, excitation of the motor only. See, if I increase the excitation, let's read option here. If I increase the excitation, obviously voltage will increase. If voltage is increasing, obviously Pmax will increase, then delta will decrease, delta is going to decrease, P will remain same. Option A is correct. Increase the excitation of generator only, that is also correct. Reducing the reactance only, that is also correct. If you reduce the reactance, then obviously Pmax is going to increase. Therefore, to make this one as constant, and delta will decrease, therefore delta will decrease. So all the given options are true or correct for the given question. Next question. The equal area criteria. Yes, actually, equal area criteria is one of the graphical method of studying stability that is applicable only for one machine system. If it is, if the machines are more than one machine, if there are more than one machine, then we have to go with another method, another mathematical method, right? Yeah, point by point method. It is called as Euler's point by point method. But here, see, the question is about equal area criteria. This is applicable for one machine system connected to infinite bus bar. So if there are two machines, what to do? We have to convert both the machines into single machine if both are swinging together with one method, if both are not swinging together with another method, right? Let's go to the next question. Let's go to the next question. Yeah, active power. Active power is a function of dash and reactive power is a function of dash. See, good question. Good question. What is P? P is equal to VI cos phi. Q is equal to VI sin phi. Right? Yeah. Now, voltage magnitude, voltage phase angle, voltage phase angle, voltage magnitude, voltage magnitude, voltage magnitude, voltage phase angle, voltage phase angle. See, I can say it is not just the active power is a function of dash. So this way we'll see. This way we'll see. S is equal to P plus JQ. Yes, I can say V is equal to mod V at an angle delta. So PE is equal to P max into sine delta. In this way we can write. So P is equal to, what is this? Mod Vs mod Vr by X into sine delta. Now, see, I can say whenever load changes, sine delta is going to change. I can write approximately active power is a function of, active power is directly proportional to sine delta. Yes, active power is a function of delta, we can say. Yes, phase angle it is. Phase angle it is. In the same way, we have formula for reactive power. Q is equal to, yes, sir. See, this way we are going to get some formula, but see, we can derive that formula. That is one of the easiest formula. See, if you want approximate formula, right? Approximate formula, right? So this is also an approximate formula only. See, mod Vs by X into mod Vs minus mod Vr cos delta. But the variation of delta is very less here, therefore we can neglect it. So Q approximately is a function of mod V. Mod V. So active power is a function of phase angle, reactive power is a function of voltage magnitude. So voltage phase angle and voltage magnitude. Active power is a function of, or reactive power is a function of voltage phase angle, and reactive power is a function of voltage magnitude. Good question it is. Good question it is. Next question. Switching operations on the transmission line have severe impact on steady state stability, transient stability, dynamic state stability, and none of the above. It is going to have severe impact on transient stability, right? That is one of the direct question. Switching transients whenever lightning occurs, or I can say whenever you are switching, whenever one of the, I see switching transients are created by faults generally. If a fault occurs, automatically circuit breaker is going to either circuit breaker is going to open its contacts once it relieves command from relay, right? One, like yes. Next, 23rd question. If the capacitance of a transmission line is increased, the transmitted power will increase. Yes, capacitance is increased. See, C increases, obviously X is going to decrease. If X decreases, Pmax will increase, then delta will decrease. If delta is decreasing, stability will increase. Right? Yeah. The capacitance of a transmission line increase. Next, question number 24. Right? The transient stability of a particle system. See, a system is said to be stable if it is, see, stability. For that, I'm taking this curve. Here, this is delta, this is PE, this is dP by d delta less than 0. So dP by d delta positive, greater than 0, stable. Here dp by d delta equal to 0. dp by d delta equal to 0, marginally stable. Here dp by d delta less than 0, it is unstable, right? It is unstable. Clear? So the point here is for a system to be stable, definitely dp by d delta must be greater than 0, and its angle must remain at a constant point. Angle should not change so unnecessarily. So I can say dp by d delta must be greater than 0, and d delta by dt must be equal to 0. Yes, option is C. Option is C. Right? Option is C. Next question, the swing equation. Swing equation for stability of a power system is represented by, swing equation is m into d square delta by dt square is equal to pa, where pa is acceleration power, but pa is equal to ps minus pe, where ps is steam input or mechanical input and p is electric power output. Look at those, which equation is correct. ps minus m into d square delta by dt square is equal to ps minus pe. Option B is perfectly matches. Next question. The industrial constant H of a 50 Hz 100 MVA hydroelectric generator is 4 megajoule per MVA. How much kinetic energy is stored in the rotor at synchronous speed? See, inertial constant H is equal to kinetic energy stored in the rotor body by MVA of the machine. So what he given? H is equal to how much? That fellow given 4. So kinetic energy is asking us to find by what is the rating of the machine? 100 MVA. So KE is equal to 400 megajoules. It is 400 megajoules. Yes, option is A, 26. Direct question. See, most of the questions easily can be solved if you follow the concepts carefully. Following the concepts carefully is very, very important. Next question. The per unit impedance, Z per unit of a three-phase system is simply how to convert from per unit to from ohmic value to per unit value. So Z per unit is equal to Z in ohm by Z base. What is Z base? Z base is equal to V base square by S base. Now Z per unit is equal to Z in ohms into S base by V base square. Yes, S base means a KV, KVA base it is. MVA base. So option is A. Z in ohm into S base. If this is in KV, it is KV square. This will be in MVA. Option A perfectly suits for the given question. Right? A 500 MVA 11 kV synchronous generator has 0.2 per unit synchronous reactance. The per unit synchronous reactance on the base 100 MVA 22 kV is changing the base. 0.2 into V base square 11 square by S base will give you its old ohmic value into, this is ohmic value, into new base is what? S base. New base is what? 100 divided by 22 square. 100 5 times gone. So 0.2 into 11 by 22 whole square means it is 1 by 4 into 1 by 5. See, 0.2 by 20 it is see 0.1 by 10 it is 0.01. Option is B. Option is B. That question that is also one of the simplest questions. See, if you know the concepts this way, very easily you can solve any given problem. Right? Next question. The following protection is not used in power transformer: earth fault protection, interturn fault protection, reverse power flow protection. Yes. The reverse power flow is not required for transformer because see, transformer is not a, see, reverse power flow is used only for generators and motors. See, motor must take the power, generator must give the power according to our requirement, right? So reverse earth fault protection is used for transformer. Yes, interturn, so between turn to not have a fault, or to recognize a fault, to not to have a fault, or to protect our system from the fault, we are going to use interturn fault. Overfluxing, yes, that is also required, but reverse power flow protection not required. See, next question. The material filled in the breather of transformer is silica gel. Yeah. See, why? Because it is going to take out the moisture from the transformer. So silica gel is used. Silica gel is used. Next question. Buckholes relay. Buckholes relay is used in the protection of transformer. Yes. Buckholes relay is going to recognize the slowly developing faults called incipient faults in the transformer. See, in the transformer tank, there will be oil. If the oil is reducing, it is going to recognize the reduction of the oil level. Once the oil crosses some certain preset value, then the Buckholes relay is going to give an alarm. Okay, it's not going to give any trip signal to circuit breaker. Next, merchant price relays are used for, yes, merchant price protection is used for generator protection. Generator protection. Okay. See, the power factor is defined as power factor cos phi is the ratio of real power to apparent power. The ratio between apparent power to reactive power, no. The ratio between true power to apparent power, yes. True power, active power, or real power are all three are same. True power, active power, or real power, all three are same. Option is B. Option is B. Right? It's a statement. Yeah. Now come here. Yeah. 34th question is a transmission line to be reciprocal, the condition is for a transmission line to be symmetrical A equal to D. This is the condition for symmetry. This is the condition for symmetry. For reciprocity, AD minus BC is equal to 1 for reciprocity. For reciprocity, right? Next slide. So AD minus BC is equal to 1. AD minus BC is equal to 1. Option is C. Next, the receiving end voltage of a long line under no load condition is under long for a long transmission line under no load and light load conditions, the receiving end voltage is going to be more than sending end voltage. This spectral effect is called as Ferengi effect. The answer it is going to be more than sending end voltage. Option is B. Distributors are designed from the viewpoint, from the point of view that see distribute two things you have to keep in your mind, that is transmission line we have designed to have low power loss, and distribution line we have designed to have low voltage drop. Yes, voltage drop in it. We have voltage drop in it, right? So we will keep in mind about the voltage drop for a distribution line, right? Next step. What is the preferred type of circuit breaker to be installed in extra high voltage system, SF6? See, if you are going for higher and higher voltages, then we have to go for SF6 circuit breaker, right? The next one. The speed of circuit breaker, see, the use of high speed circuit breakers, the speed of circuit breaker is high, immediately it is going to disconnect the faulty section from the existing system, then system is going to remain stable. Stability will be maintained, right? The options are to improve stability, to improve the stability. Next, the rate of rise of recycling voltage tripler will depend on the type of circuit breaker, the inductance of the system, the capacitance of the system, both the B and C. See, tripler is going to depend upon both the inductance and capacitance of the system, not on the type of the circuit breaker. Yes. Next question. Yeah. The Y parameter of the following network is 0, minus 1 by 2, 1 by 1, then it is reciprocal, non-reciprocal. See, he given Y parameters, from that we have to find ABCD parameters. So because we know easily about ABCD parameters, if A equal to B symmetrical, if and AD minus BC is equal to 1, then it is B. I can say reciprocal. But see, from Y parameters also we have some certain conditions, but remembering all those conditions for Y matrix, Z matrix, A, B, C, D, H, and all that is not required. We know how to convert from Y to T transmission parameters easily, right? We can do that. Yeah. Next question is in load flow studies of a power system, a voltage control bus is specified by. See, total buses are first is slack bus where mod V and delta are mentioned. Mod V is equal to 1, delta is equal to 0. And load bus or PQ bus where P and Q are mentioned. And next one is PV bus where P and mod V are mentioned. Another is voltage control bus where P is equal to 0 and mod V is mentioned, right? Yeah. What is saying in load flow studies of a power system, a voltage control bus is specified by real power and reactive power. No, real power and voltage magnitude. Yes, real power and voltage magnitude. Real power and voltage magnitude. Real power and voltage magnitude. Option is D. Option B is reactive power and voltage magnitude. No, it is a real power and voltage magnitude. Option is D. In the load flow study of power system, if P and mod V are specified at a bus, it is called as the same question as that of 41. It is a voltage controlled bus or PV bus, or it is also called as PV bus, right? When the length of an overhead power transmission line is about 50 km to 150 km, it is classified as, see, short transmission line, it is less than 80 kilometers. Medium transmission line, it's greater than 80 kilometer, but less than 160 kilometer. See, greater than 160 kilometer, then it is long transmission line. So it comes under medium transmission line, right? See, the next question is When is the Faraday effect on long overhead transmission line is experienced? When the line is lightly loaded. If the transmission line is lightly loaded or no load, then the Faraday effect is going to be experienced. Then the Faraday effect is going to be experienced. Next question. The ABCD constants of a three-phase transmission line are A, D, B, C. Given the sending end voltage is 400, the receiving end voltage under lower condition is. We know that the equation Vs is equal to AVR plus BIR. But he's saying under no load condition this is 0. So then what is he's asking about? He's asking about receiving end voltage. VR is equal to Vs by A. How much is Vs given? Vs is how much is given? 400 divided by how is the value of A? 0.8. So it is going to be 500 kV. Answer is 500. Okay, let's see whether the correct option is mentioned or not. Yes, option is B. Option is B, 500 kV. The charging reactance of a 50 km transmission line is 1500 ohms. So XC is equal to 1500 and length is equal to 50 kilometers. Now he's asking what are the charging reactance for 100 kilometers? We know that XC is equal to 1 by omega C and C is equal to C per kilometer into length of the transmission line. XC is inversely proportional to length. If length got doubled, XC is going to be half. So answer is 750 ohms. Answer is how much more? 750 ohms. That much easy it is. Correct question is. Next question. In HU transmission, the shunt compensation is done. Yes. Shunt compensation is not going to improve the stability. Minimize the occurrence of fault. Nothing with the fault. Enhance the power transfer capacity. No. All of the above. No. The answer is to improve voltage profile. The shunt capacitor will improve voltage profile and power factor, but it is not going to improve stability. Whereas series capacitor is going to improve the stability, but it is not going to improve the power factor. Series capacitor will improve the voltage, will improve the stability, but it is not going to improve the, I can say, power factor. Right? Yeah. Next question. For a fixed complex power flow in a transmission line having sending end voltage V, the real power loss will be proportional to. See, power loss is equal to actually I square into R. But a fixed power is saying he's sending fixed amount of power. Now, what is that? S is equal to V into I. This is fixed. Then V is equal to I can say I is equal to S by V. I can say I is inversely proportional to V. Right? Now, power is directly proportional to I is inversely proportional to V. 1 by V whole square into R. So power is directly proportional to 1 by V square. Power is directly proportional to 1 by V square. So the option is C. Next question. When the transmission line voltage increases, the percentage resistance drop transmission line voltage increases. See, he is saying that he is asking about a percentage drop. Okay, good question it is. See, what is the percentage resistance drop? See, that is I into R. That is I into R. If voltage is increasing for fixed power flow, if yes, see not P, let me take it as S. Let me take it as S. Good question it is. S is equal to V into I. For a fixed S, if voltage is increasing, obviously current will decrease. If current is decreasing, then obviously the voltage drop is going to decrease. Yes, it is going to decrease. The skin effect of a conductor will reduce as the resistivity of the conductor increases, permeability of the conductor increases, diameter increases, frequency increases. So he is asking about when skin effect will decrease. Diameter increases, no. Frequency increases, no. Permeability increases, no. The resistivity of the conductor increases. See, skin effect, skin depth delta is directly proportional to under root of omega into sigma into mu, where omega is 2 pi f is directly proportional to under root of frequency into sigma resistivity and mu. Sigma is conductivity. Okay, sigma is conductivity. See, if conductivity, I can say, inversely proportional to this, inversely proportional. Skin depth is inversely proportional to that. More is skin depth, less is the skin effect, right? Now, if frequency is increasing, delta will decrease, skin effect will increase. Skin effect will increase. Therefore, increase in frequency, no. If sigma is increasing, sigma increases means rho decreases. Sigma is increasing, delta will decrease. Right? Now, what is the question? Resistivity of the conductor increases. Resistivity is increasing. Okay, let's do this way. Resistivity increasing. Resistivity is increasing. Conductivity is decreasing. If conductivity, this sigma is decreasing, then delta is going to increase, then skin effect is going to decrease. So option is A. Option is A. See, let me take one more time that explanation. Yeah, skin depth delta is directly proportional to 1 by under root of F sigma mu. F is frequency, sigma is conductivity, and sigma is reciprocal of rho, that is resistivity, right? Mu is permeability, right? And delta is inversely proportional to skin effect. If more is delta, less is skin effect, right? If less is delta, more is skin effect. Now, if frequency increases, delta decreases. Delta decreased, skin effect is more. That is wrong, right? If if mu increases, delta decreases. Delta decreasing means skin effect is going to increase. Next one is rho. If rho is increasing, sigma is decreasing. If sigma is decreasing, delta is increasing. If delta is increasing, skin effect is going to decrease, right? So this is about that question. See, Oil India Limited is one of the prestigious job, and the examination will be, I can say, easy to moderate level of this kind of questions only you'll get. Join your hands with YourPedia to accelerate your preparation. YourPedia is one of the authentic, largest online platform in India for PSC examination preparation. So, with the mentors of YourPedia, you can practice your All India exam preparation. Thank you.